Basel than it is in Beijing. Basel being in Switzerland, Beijing being in China. Why is a standardized goods basket more expensive in Frankfurt than in Ho Chi Minh City? And the reply, a large part of the reply is in the models of Béla Balassa and Paul Samuelson. Now this is one of these interesting situations where two people had kind of the same idea at the same time. We have that often in economics. We have the Solow model of economic growth, which is also known as the Solow-Swan model, because there was another guy called Swan who did the same thing at the same time. There's the Mundell-Fleming model of policy in open economies, going back to Mundell and Fleming. And here we have a Hungarian economist, Béla Balassa, and Paul Samuelson, which is one of the most important figures in modern economics. Now, how does the Balassa-Samuelson model work? Well, it is a model of the real exchange rate that goes beyond purchasing power parity. So purchasing power parity is now left behind and rationalize the observed relationship between income levels, growth, and the real exchange rate. And the key idea is, and this is kind of now the MBA version, due to higher productivity levels in traded goods industries, richer countries are characterized by higher relative prices of non-traded goods, which pushes down the real exchange rate and pushes up prices, and that makes the exchange rate look overvalued. So to tell the story first, right? Suppose you have people cutting hair in Zurich and you have people cooking chemicals in Basel. Now, the chemicals industry is a very important industry in Switzerland. Now, suppose that the chemicals industry is very productive and they can afford paying very high wages. And suppose that people can decide not to cut hair in Zurich anymore, but instead to cook chemicals. So they don't need any special qualification for doing that. Now, if the wage of those people cutting hair in Zurich was not roughly equal to the wage of those people cooking chemicals in Basel, everybody would, cutting hair in Zurich would drop his or her scissors and move to Basel and cook chemicals. That would raise the wages of people cutting hair in Zurich because there would be so few left. So that's the point. And this, of course, would increase the price of a haircut. And you know what? A haircut in Zurich is super expensive. Don't get your haircut in Zurich. Right? That costs you an arm and a leg. Why? Well, of course, the Swiss will tell you, well, because the quality is so high of the haircut. But people knowing economics, they say, no, that's not about the quality of the haircut. That's about Balassa-Samuelson. You guys are paid very well in Zurich for cutting hair because otherwise you would take jobs in Basel where you would get a very high wage. So it's the high productivity of the tradable sector that A, leads to high per capita GDP, and B, pushes up the wage level in non-traded industries. Now, please bear in mind that, so when you, usually when I teach in these central bankers courses, when I teach in these central bankers courses in Gärtensee, they are very busy, and Gärtensee is very remote, right? It's somewhere, in the countryside. But on a Thursday evening, this entire group is taking to Bern. It's like, it's a fancy thing because people come really from all over the world. We have someone from Norway, we have someone from Germany, we have someone from the Bank of England, but we also have someone from Cambodia, we have someone from Peru, we have someone from Tanzania. And these guys go shopping, and some of them are really shocked by what they have to pay for pretty, simple things. So you go into the supermarket in Zurich and you pay a price for a banana. You pay, the price that you pay for a banana is the price that you pay for 50 bananas, or even actually 50 bananas and 10 mangoes in Vietnam. And now the reason for that is not that the banana in Zurich is better, it's that the person who's putting the banana into the shelf is paid much more in Zurich than it is paid in Ho Chi Minh City or in Binh Duong province, right? And this is the reason why we have why when you go to Zurich, when you go to Norway, why you think this is an expensive country, because the overall price level is so high, and that has to do with the fact that people are getting high wages because otherwise they would move to the high wage industries. Now, in the high wage industries, the high wages are justified by high productivity. In services, it might just be that there's high wages, right, because of intersectoral labor mobility. Now, this was the MBA version of the Balassa-Samuelson model. Now let's dig much deeper, right? So let's go beyond MA teachings. Now, the first thing we have to do, we have to illustrate the relevance of non-traded goods prices. And to do that, I need some space. And I need some pens. And I move to the right-hand side because that's where the majority of people are. Right? I'm kind of. Good, good, good. Alrighty, so, okay, now what is the assumption? The assumption is that you can describe the CPI as a weighted average, geometric average, Cobb-Douglas version almost, of a traded component and a non-traded component. So PTH is the price index of traded goods basket at home, and PN is the price index of non-traded goods. So you can separate things. Some of them are traded, others are non-traded. It's not that easy, as I said a couple of minutes ago, right? But here we just separate into pure traded goods and pure non-traded goods. Okay, what's the next thing? The next thing is we assume that the foreign country has about the same structure, both in terms of consumption habits. So the foreign price index looks like this. Right? And so we have, here we're making a very strong assumption, namely that the weight of tradable goods or traded goods in the foreign consumption basket is the same as in the home, right? The gamma is the same. We could, of course, allow for differences and say, well, maybe in some country the services or the non-traded component is larger or smaller, but here we abstract from that. And then we simply compute the CPI-based real exchange rate, which is take the nominal exchange rate times the foreign CPI divided by the domestic CPI. That's what we do when we compute the real exchange rate. Now, let's take logs and reshuffle expressions. So let's do that. Let me just copy what we had on the previous slide, which is the nominal exchange rate times the traded goods prices in the foreign country times to the power of gamma times the non-traded prices in the foreign country to the power of 1 minus gamma, and we divide by the traded goods prices in the home country to the power of gamma, traded goods prices. Okay. Next thing is we take logs. Now taking logs turns the whole thing into a linear thing. Right, so we have the log ET, we have plus gamma log PT TF plus 1 minus gamma log PT NF minus gamma log PT TH minus 1 minus gamma log PT NH. Good. Now we relabel things and call this fellow here lowercase CPI. We call that fellow here lowercase e. We call this thing lowercase PTF. We call this thing lowercase PTNF. We call this thing lowercase PTTH, and we call this thing lowercase PTNH. So far, so good. Now, here's the weird thing. So this is equivalent to saying Qt CPI equals ET. Now let me add this thing and let me subtract it. I'm doing something, it's like I say, now if I say 5 equals 5, it's the same thing as saying 5 is the same as 5 plus 1 million minus 1 million. Why am I doing this? You will see. So the next thing is I'm subtracting this and I'm adding it, which I'm allowed to do. It looks pretty redundant, but you'll see what it's good for. Now the rest of the thing I'm just copying from above. You have PT TF plus 1 minus, plus 1 minus gamma PT NF minus gamma PT TH minus 1 minus gamma PT NH. Good. Now, take this, this, and that, and you get Qt CPI equals ET plus PT TF minus PT TH. Of course, we have a lot of leftovers here. But this thing here is the same as this. And this thing here is the same thing as this. And you see there's always a 1 minus gamma involved. Actually, here it's minus 1 minus gamma. It's gamma minus 1. Here it's 1 minus gamma. Here is the 1 minus gamma as well. You have the 1 minus gamma as well. So by the end of the day, what you get is plus 1 minus gamma PT NF minus PT TF minus PT NH minus PT TH. And this is exactly the thing that we'd have down here. If I didn't screw up, I think I didn't. So this is a super useful decomposition of the real exchange rate because it splits the real exchange rate into two parts, essentially. The first part is the relative price of traded goods. So this is the price of traded goods in the foreign country, in the foreign currency as well, and it's, please note that this thing here is the log of ET times PT TF, right? So it's the log of the foreign price of trade goods times translated into the domestic currency using the nominal exchange rate. Please also note that this is the log of PTNH over PTTH. So you have two components. One that is referring to traded goods prices, and the other one that's related to actually a difference in differences, if you want. It's a difference between the relative price of non-traded goods in the home country. Hello. Ah, good. Here's another picture. Do you need this as well? Bye-bye. Now, the question I'm asking myself, is it because they need this picture somewhere else, or because they wanted to get me? So, we don't know. Okay, so anyway, so the pictures are gone. I should have taken a picture of the pictures. Okay, I didn't. Now, how do we proceed? We proceed as follows. Now, this is the price of domestic traded goods relative to foreign traded goods. Actually, it's the other way around. It's the price of foreign traded goods relative to domestic traded goods. I have to change that at some point. But you see the point, right? This is just the relative price of the traded goods basket. This is the price of domestic non-traded goods relative to domestic traded goods, right? It's the log of Pn over Pt in the home country. Now, if you are willing to assume, or for a given foreign prices, a real appreciation is driven by, note that a real appreciation is Q going down. So Q goes down if domestic traded goods become more expensive relative to foreign traded goods, okay? Or if domestic non-traded goods, they become more expensive relative to domestic traded goods. So if Pn over Pat goes up, this difference goes up, and since there is a minus, it pulls down the real exchange rate. Again and again, price notation, when Q goes down, that means a real appreciation, right? Now, if we assume that absolute PPP holds for traded part of the domestic CPI, then we can set this equal to 0. So suppose that you assume that traded goods are goods that can be costlessly traded, and so the law of one price prevails, and then you set this equal to 0, because the price of the traded goods in the home currency equals the price in the foreign currency times the nominal exchange rate. Then all that's left is this non-traded thing. So consequences is the CPI-based real exchange rate is only driven by relative prices of non-traded goods. Now, let's assume, without loss of generality, that the relative price of non-traded goods are constant in country F. Right? So we set this equal to 0. By the end of the day, what we get is we get the CPI-based real exchange rate is just minus 1 minus gamma Pn of H minus PTH. So, so you have a real appreciation when this ratio increases, right? Because of the minus. So when this difference increases, the CPI-based real exchange rate, or the log of the CPI-based real exchange rate, goes down. Now, Balassa-Samuelson is about explaining the increase in that. So far, we haven't done Balassa-Samuelson yet. We have just prepared the ground. Now, the next step will be to explain Balassa, to explain that why this should go up in increasingly prosperous countries.
Can I ask a bit more about the assumption too?
Yes.
Can you explain a bit more? Like, where would the price of non-traded goods constant impact? What does it mean?
It's just an assumption. I mean, the assumption is, we could allow this to move and that to move. And then the question is, what moves more? Right? Then, now, so if this goes up and this goes up as well, then the question is, what goes up by more? Now, this, of course, probably the more realistic case, that relative price of non-traded goods move in both countries, so home country and foreign country. But then we would have to make the decision about where does it move more, because if this moves more than that, then we would get this result. And so what we do is we essentially, just for simplicity, we say this doesn't move at all. And so it moves at all, no, doesn't move at all. So we could set it equal to a constant. And if we set it equal to constant, we can set it equal to 0. Then it disappears from the model. I mean, it's a valid question. It doesn't, I mean, this setting, basically what that says is that non-traded goods price and traded goods price are the same in the foreign country, which is kind of a weird assumption. But if we said non-traded goods prices are just 5 times price of traded goods prices, or 0.5, then we would have a number here, but which is a constant. I think the key assumption is that this doesn't move around over time. And that is, of course, if we didn't make this assumption, if we allowed this to move around, then we would be left with a question whether this moves by more than that or that moves by more than this. Thanks. Good. So the theory by Bella, Balassa, and Samuelson, Paul Samuelson, I mean, you came across the name of Paul Samuelson, right? I mean, this is the godfather of modern economics. You could argue. So the key idea is, even if the law of one price holds for traded goods, prices of non-traded goods depend on domestic factor prices. So you have the law of one price pinning down the prices of the traded goods, because that's determined on world markets. Now, this doesn't hold for non-traded goods, because non-traded goods are non-traded, and so they depend on domestic costs. First and foremost, wages. Now, productivity advances in tradable sector, well, that shouldn't be tradables, it should be traded, sector in which countries push up wages, and higher wages feed into higher prices of non-traded goods. And higher non-traded goods prices increase the aggregate price level and lead to a real appreciation. So there are various versions of the Balassa-Samuelson model. On the following page, we will present, that's me, a version with perfect capital mobility and a constant interest rate, right? So there's various ways of presenting Balassa-Samuelson. Let me just present you one version. So let's get serious about Balassa-Samuelson. Just to make sure I'm not Well, how do we start? We start with the assumption that there's 2 production functions, one for traded goods and one for non-traded goods, right? And they're both Cobb-Douglas. Please note, and that's important, we have total factor productives, which are sector specific, and we have these exponents, which are sector specific. So alpha t is not necessarily equal to alpha n. Good. Now the first thing that we okay, let me spell out the things before I write stuff on the whiteboard. Now, perfect capital mobility implies, and now please note where the traded goods price is the numeraire, that the marginal product of capital equals the real interest rate, right? So the marginal value product of capital has to be equal to the interest rate. So here we have the marginal product of capital. Here we have the marginal product of capital times the non-traded goods price, right? Because and what is lowercase k? Well, it's just the capital labor ratio in the specific industry. How do you get that? Well, you get it by saying if yt equals at t ktt to the power of alpha t ltt to the power of 1 minus alpha t, then taking the derivative of output with respect to capital gives you alpha t, ATT, KTT to the power of alpha t minus 1, LTT to the power of 1 minus alpha t, and that's just equivalent to saying, oh, right, that has to be equal to R. This is, by the way, a condition that we've met last week, right? And that's equivalent to saying that alpha t, ATT, KTT 1 minus alpha t equals R. And in the non-traded goods industry, please note this is the marginal value product, so the price plays a role. So you have to, it's the same thing, but the price is not equal to 1. Good. Okay. Next thing is intersectoral mobility of labor, and that's the important assumption.
Professor,
Yes.
This is the power of alpha t minus 1, right? The one before the equal.
Oh, yeah. Thank you. Thanks, and sorry. Good. So here are two assumptions. Again, we have perfect competition. So the marginal value product of labor has to equal the price of labor. Now, the marginal value product of labor is the price of traded goods times the marginal product of labor in the traded goods industry. The marginal value product of labor in the non-traded goods industry is the price of the non-traded good times the marginal productivity. I'll do it in a second. Now, importantly, and I'm not allowed to write on that screen, this is applied by intersectoral labor mobility. This is the assumption that if you are paid a higher wage in this industry than in that industry, you will move to that industry. So the only labor market equilibrium with perfect intersectoral labor mobility implies that the wage has to be the same. Now, let's first do the nerdy stuff, right? And let me hope that I'm not going to screw up this time. This is 1 minus alpha t, ATT, KTT to the power of alpha t, LTT to the power of minus alpha t, and that has to be equal to W, and that's equivalent to saying 1 minus alpha t, ATT, KTT to the power of alpha t equals WT. So that's the logic. Good. Here are notes, but we'll use the whiteboard, so let me continue. And let me pick some pens from that side. So the first thing is we use this thing, right? And let me call it star.